There's a button inside your car that you have pressed 1,000 times and never once used correctly. It is right there on your dashboard or your steering wheel or your center console, depending on your make and model, sitting in plain sight with a label you recognize and a function you think you understand. You have been using it wrong since the day you drove the car off the lot. And the way you have been using it is costing you fuel, costing you battery life, costing you brake wear, and in certain driving conditions, costing you the kind of control over your vehicle that could be the difference between a close call and a collision. The correct way to use this button was designed by Japanese engineers who spent years testing it under conditions that simulate real-world emergencies, extreme weather, and long-term wear patterns. The correct method was taught to every technician in the Japanese domestic market as part of standard vehicle orientation. And somewhere between the engineering lab in Japan and the sales floor at your dealership, the explanation of how this button actually works was reduced to a single sentence in your owner's manual that tells you what the button does, but completely omits when, why, and how to use it in the way the engineers intended. That omission is not a space issue. Your owner's manual has pages dedicated to how to adjust your cup holder and how to sync your phone to the Bluetooth system. The omission exists because the correct use of this button reduces service visits, extends component life, and eliminates some of the most common wear-related repairs that generate consistent revenue for the service department that was supposed to explain it to you when you picked up your keys. My name is Kenzo. I run Secret Japanese Garage, and what I am going to walk you through today is not a list of secret buttons that do magical things. I am not going to tell you that pressing 3 buttons in a sequence unlocks a hidden mode that doubles your horsepower. That is not how cars work, and anyone telling you otherwise is insulting your intelligence. What I'm going to show you is something far more valuable and far more real. I'm going to show you the buttons and controls that are already part of your daily driving experience, the ones you already touch, the ones you already use, and I'm going to show you that the way you are using them is a simplified, incomplete, and in some cases actively harmful version of how Japanese engineers designed them to be used. These are not hidden buttons, they are misunderstood buttons. And the gap between how you use them and how they were designed to be used is a gap filled with unnecessary wear, unnecessary fuel consumption, unnecessary repair costs, and unnecessary risk. In Japan, this gap does not exist because the knowledge is transferred at the point of sale, reinforced at every service visit, and treated as fundamental automotive literacy. In Western markets, the gap is enormous because closing it would require the service industry to educate you in ways that directly reduce your dependence on the service industry, and that is a conversation that no service advisor has any incentive to start. I want to tell you about how I first discovered the depth of this gap because the story reveals something important about the difference between Japanese and Western automotive culture that goes beyond any single button or feature. 11 years ago, I spent 3 weeks embedded in a Toyota dealership service department in Chiba Prefecture just east of Tokyo. I was there as part of an informal exchange arranged through a contact who worked in parts distribution. The dealership was mid-sized, servicing mostly Corollas, Prius models, Aquas, and the occasional Crown. Nothing exotic, nothing performance-oriented. Regular cars owned by regular people who use them for commuting, errands, and family life. What struck me on the very first day was the delivery process. When a customer purchased a new car or a certified pre-owned vehicle from this dealership, the delivery did not end when the customer signed the paperwork and received the keys. There was a second phase. A technician, not a salesperson, not a delivery coordinator, a trained technician, spent between 45 minutes and an hour with the customer in the car, going through every control, every button, every system, not at the level of this is your climate control and this is your stereo, but at the level of this is how the recirculation button interacts with your climate system. Under different conditions, this is when to use it and when not to use it. This is what happens to your evaporator core if you use it incorrectly over time. And this is how the engineers intended you to manage cabin air in different seasons. I watched this process 4 times with 4 different customers over my first 3 days. Each time, the technician covered the same controls, but adapted the depth of explanation to the customer's experience level and driving patterns. A customer who commuted 90 minutes each way on the expressway got different guidance about cruise control usage than a customer who drove 15 minutes through residential streets. A customer in a hybrid got different guidance about the EV mode button than a customer in a conventional powertrain. The guidance was personalized, technical, and practical, and it was all focused on one outcome: helping the customer use the car the way the engineers designed it to be used so that the car would last as long as the engineers designed it to last. I asked the service manager why they invested this much time in delivery education when the customer had already bought the car and the sale was complete. His answer was immediate and delivered without a trace of irony. Because the car's reputation is our reputation. If the customer wears out the brakes in 20,000 kilometers because nobody showed them how to use engine braking, that customer blames the car. If the battery dies in 3 years because nobody explained how the electrical system manages parasitic draw, that customer blames Toyota. Every failure that education would have prevented is a failure that damages the brand. We do not sell cars, we sell the next 40 years of this customer's trust. I have replayed that sentence in my mind hundreds of times since then. We do not sell cars, we sell the next 40 years of this customer's trust. Compare that philosophy to the delivery experience at any Western dealership. You sign the papers. Someone shows you how to pair your phone. They point at the dashboard and say any questions. You drive away. And everything that happens to your car from that moment forward, every premature wear item, every preventable repair, every inefficiency caused by incorrect use of a system you were never properly taught, all of it becomes your problem and their revenue. The knowledge that would have prevented it was never transferred. Not because it does not exist, because the business model works better when it does not. Let me start with the button I referenced at the beginning because it is the single most misused control in every Japanese car on Western roads, and the financial impact of that misuse over the life of the vehicle is staggering. The recirculation button, every car has it. It is the button on your climate control panel with the icon showing an arrow circling inside the outline of a car. You know what it does in the most basic sense? It switches between pulling fresh air from outside and recirculating the air already inside the cabin. Most Western drivers use it in one of two ways. Either they never touch it and leave the system on fresh air permanently, or they turn it on when they are stuck behind a diesel truck or driving through an area that smells bad, and then they forget about it and leave it on for days or weeks without realizing it. Both of these approaches are wrong. Both of them cause measurable damage to your car over time. And the correct approach, the one taught to every customer at that Chiba dealership and practiced by every informed Japanese driver, is something that no Western dealer, no service advisor, and no owner's manual has ever adequately explained. Here is what happens when you leave recirculation off permanently and run fresh air at all times. Your climate control system is constantly pulling outside air through the cabin air filter, cooling or heating it, and pushing it into the cabin. In hot weather, this means the system is continuously working to cool hot outside air rather than recooling already cooled cabin air. The compressor runs harder, the evaporator works harder. Fuel consumption increases because the compressor load on the engine is higher than it needs to be. On a car that costs $2,000 a year in fuel, the difference between running fresh air and correctly using recirculation in hot conditions is between 5 and 10% of your total air conditioning fuel penalty. That translates to $40 to $80 per year in fuel savings that you are leaving on the table because nobody explained the thermodynamic logic behind a button you already have. In Japan, drivers are taught to start with recirculation on when first cooling a hot cabin. Allow the system to bring the interior temperature down using already partially cooled cabin air rather than fighting a continuous stream of hot outside air, and then switch to fresh air once the cabin reaches the target temperature. This reduces compressor runtime, reduces fuel consumption, and reduces wear on the compressor clutch, which is a component that costs between $300 and $800 to replace depending on your vehicle, and which wears in direct proportion to how hard and how long the compressor runs. Now here is the other side. Leaving recirculation on permanently is equally destructive but in a completely different way. When you recirculate cabin air continuously without periodically introducing fresh air, moisture from your breath and your body accumulates inside the cabin. That moisture has to go somewhere. It condenses on the coldest surface in the climate system, which is the evaporator core, the component hidden inside your dashboard that actually produces the cold air. Under normal operation with periodic fresh air cycling, the evaporator gets wet, drains through a tube under the car, and stays relatively clean. Under continuous recirculation, the evaporator stays wet constantly without adequate drying cycles. This creates the perfect environment for mold and bacterial growth inside the evaporator housing. That musty, sour smell that comes from your vents when you first turn on the AC after the car has been sitting, that is biological growth on your evaporator core, and once it establishes itself, the only way to fully eliminate it is a professional evaporator cleaning that costs between $150 and $400, or in severe cases, evaporator replacement that can exceed $1,000. The correct protocol, the one taught in Japan, is to cycle recirculation off for 5 to 10 minutes out of every hour of driving to allow fresh airflow across the evaporator, promote drying, and prevent moisture buildup. In the last 5 minutes before you reach your destination, switch to fresh air with the AC compressor off and the fan running. This pushes ambient temperature air across the evaporator, evaporates residual moisture, and leaves the system dry when you park the car. A dry evaporator does not grow mold. A dry evaporator does not produce odors. A dry evaporator does not need a $400 cleaning. Japanese engineers designed the recirculation system to be actively managed by the driver. Western drivers were never told this. So they either leave it off and waste fuel and wear out compressors, or leave it on and grow mold colonies inside their dashboards. Both outcomes generate service revenue. Both outcomes were preventable with a 60-second explanation at delivery. The explanation was never given. The second button I need to talk to you about is one that most drivers interact with every single day without realizing that they are using approximately 10% of its designed functionality. The cruise control button, or more specifically, the cruise control system, which on most Japanese cars built in the last 15 years, includes capabilities that go far beyond maintaining a set speed on the highway. I am not talking about adaptive cruise control, which is a separate radar or camera-based system that maintains distance from the car ahead. I am talking about the basic cruise control that exists on virtually every Japanese car, including base models with no advanced driver assistance features. In Japan, cruise control is taught as a fuel economy tool, a brake preservation tool, and an engine management tool. In Western markets, it is taught as a convenience feature. Set your speed. Take your foot off the gas. That is the full extent of the education most Western drivers receive. Here is what they are missing. Most Japanese cruise control systems have increment and decrement functionality that allows you to adjust your set speed in small increments, typically 1 mile per hour or 1 kilometer per hour at a time, using the plus and minus buttons on the steering wheel stalk or controls. Western drivers who use cruise control at all typically set it and forget it. They set 70 miles per hour on the highway and leave it there until they need to brake or exit. Japanese drivers are taught to use the increment and decrement function actively throughout the drive as a precision fuel management tool. When approaching a gentle uphill grade, rather than allowing the cruise system to maintain speed by adding throttle and increasing fuel consumption to fight gravity, a Japanese trained driver will tap the decrement button 2 or 3 times, allowing the speed to drop by 2 or 3 miles per hour on the uphill. The car maintains a nearly constant throttle position and fuel flow rate instead of increasing fuel delivery to fight the grade. The speed reduction is so small that it has zero practical impact on travel time. On a 30-mile highway stretch with 3 moderate grades, this technique can reduce fuel consumption by 8 to 12% compared to rigid speed maintenance. Over a year of commuting, that is real money. Over 5 years, it is hundreds of dollars, from a button you already have, used in a way nobody ever taught you. On the downhill side, instead of allowing the car to accelerate beyond the set speed and then rely on engine braking or worse, brake application to maintain speed, the Japanese approach is to tap the set button at the crest of the hill, allowing the cruise system to capture the current speed as the new set point, then let gravity assist acceleration naturally on the downhill before resetting to the original speed on the flat. This technique, called rhythm cruising in some Japanese driving education materials, treats the cruise control not as a fixed speed clamp, but as a dynamic speed range manager that works with terrain rather than against it. The engine works less, the brakes work less, the fuel consumption drops, the component wear decreases, and the only thing required is an understanding of the system that goes deeper than set and forget. But here is where the cruise control conversation gets really interesting, because there is a function within the cruise control system on most Toyota, Honda, and Mazda vehicles that I have never heard a Western driver discuss, and that Japanese driving instructors teach as one of the most important safety and efficiency features in the car: the cancel function versus the off function. On most Japanese cars, the cruise control stalk or button set has both a cancel function and an off function, and they do different things. Cancel disengages cruise control, but remembers your set speed. Off disengages cruise control and erases the set speed from memory. Most Western drivers use cancel and off interchangeably, or they just tap the brake to disengage cruise and never touch the stalk at all. In Japan, the distinction between cancel and off is taught as a critical operational skill for a specific reason. When you tap the brake to disengage cruise control in a situation where you need to slow down temporarily, your set speed is still stored in the system. When traffic clears or the situation resolves, you press resume and the car accelerates back to your stored speed. Here's the problem. If your stored speed was 70 miles per hour and you brake to 45 miles per hour for a traffic situation and you press resume, the car will accelerate aggressively from 45 to 70. That acceleration rate is significantly more aggressive than most drivers expect or intend. It applies full throttle in many cases. It surprises the driver. It catches surrounding traffic off guard. And in situations where the traffic situation has not fully resolved, it can close distance dangerously fast. The Japanese protocol is to use cancel instead of braking when you want to temporarily disengage, and then when you are ready to resume, to check your stored speed against your current speed. If the gap is more than 10 miles per hour, you do not resume. You use the set function to capture your current speed and then increment up to your desired speed gradually. If the gap is less than 10 miles per hour, resume is appropriate because the acceleration will be gentle and predictable. This protocol prevents the aggressive resume acceleration that catches drivers off guard, reduces the throttle spike that wastes fuel, and eliminates the unnecessary brake wear that comes from drivers who resume too fast and then immediately brake because the car accelerated more than they expected. None of this is complicated. All of it is built into the system. The engineers designed cancel and resume with this exact usage pattern in mind. Nobody at any Western dealership has ever walked a customer through the difference between cancel, off, brake disengage, and resume, or explained the safety and efficiency implications of each. The button distinction exists, the knowledge transfer does not. The third control I need to address is one that generates more confusion, more misuse, and more unnecessary mechanical damage than perhaps any other driver-operated system in a modern Japanese car. The electronic parking brake and the auto hold function that is increasingly paired with it. If your car was built after 2015, there is a strong chance it has an electronic parking brake instead of a traditional hand lever or foot pedal parking brake. And if it has an electronic parking brake, there is a reasonable chance it also has an auto hold function, usually activated by a button near the electronic parking brake switch, labeled with a capital A inside a circle, or the words auto hold. Here is what auto hold does. When activated, after you come to a complete stop, the brake system maintains braking pressure electronically without you keeping your foot on the brake pedal. When you press the accelerator, the system releases the brake automatically and you drive away. In traffic, at red lights, in drive-thrus, anywhere you stop repeatedly, auto hold allows you to take your foot off the brake and rest it while the car remains stationary. This sounds simple. It sounds like a comfort feature. Japanese engineers designed it as far more than that, and the distinction between how they intended it to be used and how Western drivers use it has significant implications for brake wear, fuel consumption, and transmission health. In Japan, auto hold is taught as the correct way to hold the vehicle at stops, not the parking brake, not holding the brake pedal. Auto hold. Here is why. When you hold the brake pedal at a stop in a car with an automatic transmission, the engine is idling against the torque converter, which is trying to push the car forward against the brakes. This creates a constant load on the drivetrain, generates heat in the torque converter fluid, and wastes fuel. The amount is small per stop, but over a year of daily commuting with dozens of stops per trip, the cumulative fuel waste and transmission fluid heat cycling is measurable. When you use the parking brake at stops, which some drivers do to avoid holding the brake pedal, you are applying the rear brakes mechanically while the front brakes are released. This can create uneven brake wear over time and, on electronic parking brakes, increases the cycle count on the parking brake actuator motor, which is a component with a finite lifespan. Auto hold is designed to be the optimal middle ground. It maintains hydraulic braking pressure at all four wheels evenly, without requiring you to keep your foot on the pedal, and it communicates to the engine management system that the vehicle is in a held state, which on many Japanese cars triggers a subtle idle reduction that decreases fuel consumption while stopped. The system was specifically engineered to be the default hold method, not an option, not an alternative, the default. In Japan, drivers activate auto hold when they start the car and leave it active for the entire drive. It becomes the car's standard behavior at every stop. In Western markets, most drivers either do not know the feature exists, do not understand what it does, activate it once by accident, and then turn it off because it feels unfamiliar, or use it inconsistently, which means they get none of the cumulative efficiency and wear benefits that come from consistent use. On vehicles where auto hold must be reactivated every time the car is started, Japanese drivers press that button as instinctively as they press the engine start button. It is part of the startup sequence. Engine on, seatbelt on, auto hold on, drive. That three-step sequence was part of the delivery education at the Chiba dealership. Every customer was taught it. In Western markets, auto hold is mentioned in the owner's manual, described on the manufacturer's website, and then never discussed again by anyone who interacts with the customer. The button sits there, unused, while the driver holds the brake pedal at every red light, loads the torque converter, wastes fuel, and wears brake components unevenly for the next 10 years. The fourth control is one that I approach carefully because the misuse of this control does not just cost money. It costs safety, and the gap between how Western drivers use it and how Japanese engineers designed it to be used is potentially dangerous. I am talking about the headlight system, specifically the difference between the auto headlight position and the dedicated on position, and why the position you leave your headlight switch in affects your visibility, your safety, and in some cases the safety of drivers around you in ways you have never considered. Most modern Japanese cars have a headlight switch with 4 positions: off, parking lights, on, auto. The majority of Western drivers leave the switch on auto permanently and never think about it again. The auto setting uses an ambient light sensor, typically located on the dashboard near the base of the windshield, to detect when exterior light levels drop below a threshold and automatically turn on the headlights. This sounds ideal. The car manages the lights for you. You never drive in the dark without headlights, except the system has blind spots. And those blind spots create situations where you are driving with less visibility and less conspicuity than you should have, and you have no idea because you trusted the system to handle it. The ambient light sensor responds to overall light levels, not to driving conditions. In heavy overcast weather, during rain, in fog, at dusk when the sky is still technically bright but visibility is reduced, the auto system may determine that there is sufficient ambient light and keep the headlights off. You are driving in conditions where other drivers have difficulty seeing you, where road surface contrast is reduced, where your own forward visibility would benefit from headlights, and your car has decided that it is not dark enough to turn them on. In Japan, driving education includes explicit instruction on when to override the auto system and manually switch to the on position. Rain, fog, heavy overcast, dusk, dawn. Driving through tunnels where the transition from bright to dark and back happens faster than the auto sensor can respond. Driving on roads with heavy tree canopy where light levels fluctuate rapidly. In all of these conditions, Japanese drivers are taught to switch from auto to on because the headlights serve two functions, illumination for you and conspicuity for others, and the auto system only optimizes for the first function. Your headlights in rain are not primarily for you to see the road. They are for the driver 3 cars ahead of you to see you in their rain-covered mirrors. They are for the driver approaching from a side street to see you through the spray. They are for the pedestrian at the crosswalk to see you against the gray backdrop of a wet road on an overcast day. The auto system does not consider these factors. It considers only ambient light levels. And by delegating your visibility and conspicuity entirely to a light sensor on your dashboard, you are creating gaps in your safety envelope that you are not aware of because the system tells you everything is fine. There is a second dimension to the headlight conversation that relates to the daytime running light system and how it interacts with the auto headlight setting in ways that create a specific and dangerous misconception. On many Japanese cars, daytime running lights activate the front lights at a reduced intensity whenever the engine is running. This gives drivers the impression that their lights are on. The dashboard is illuminated. The front of the car appears to have headlights active. But daytime running lights on most models do not activate the tail lights. Your front is visible, your rear is dark. In conditions where the auto system has not triggered full headlights, low light, rain, fog, overcast, you are driving with a lit front and a dark rear. Drivers behind you see a car with no taillights, reduced visibility against the road surface, and no clear indication of your position, speed, or braking until you actually touch the brake pedal and the brake lights illuminate. In Japan, this discrepancy is taught explicitly during driver education. Drivers are told that daytime running lights are not headlights, that the auto system does not guarantee tail light activation in marginal conditions, and that the manual on position is the only position that guarantees full lighting front and rear in all conditions. Western drivers are almost universally unaware of this distinction. They see light coming from the front of their car and assume the taillights are on. They trust the auto system to manage all of their lighting needs. And they drive through rain and fog and dusk with dark tail ends because nobody ever told them that the system they trusted does not do what they assumed it does. A rear-end collision in reduced visibility conditions where your taillights were not active because the auto system did not trigger them is a collision that a manual switch to on would have prevented. That switch takes 1 second. The knowledge to make that switch should have been provided at delivery. It was not. In Japan, it is provided. In Japan, it is reinforced at every vehicle inspection. In Western markets, the headlight switch is demonstrated during delivery at the level of this is auto and this is on, and most people leave it on auto. And the conversation ends there. It ends before the part that matters. It ends before the part that could save your life. The fifth and final control I want to address today circles back to something fundamental about the relationship between you and your car, the trip computer and its deeper functions. Every modern Japanese car has a trip computer that displays information on the dashboard or the central screen. Most Western drivers interact with it at the most superficial level. They see the fuel economy average. They see the distance to empty. They see the trip odometer. They cycle through these displays occasionally, absorb the numbers passively, and extract almost no actionable value from them. In Japan, the trip computer is taught as the driver's primary feedback instrument, not a passive display, an active coaching tool. And the depth of information available in most Japanese car trip computers goes far beyond what most Western drivers have ever accessed. Let me show you what I mean with a specific example. On most Toyota and Lexus models, the trip computer has a display mode that shows you the elapsed time, distance, average speed, and average fuel economy for your current trip. Most drivers have seen this screen, but within this screen, on many models, there is a function accessed by pressing and holding the display cycle button for 3 to 5 seconds that splits the display into 2 concurrent trip records, Trip A and Trip B running simultaneously but independently resettable. This dual trip function was designed by Toyota engineers for a specific purpose that is explained in Japanese owner education materials but absent from Western documentation. Trip A is intended to track your current tank of fuel from fill up to fill up. You reset it every time you refuel. It gives you actual fuel economy for that specific tank, allowing you to compare real-world performance across different fuel brands, different driving conditions, and different seasons. Trip B is intended to track longer-term patterns. You reset it monthly, seasonally, or at specific mileage intervals. It gives you trend data. Is your fuel economy improving or declining over time? A consistent downward trend in Trip B average fuel economy, even when Trip A shows normal individual tank numbers, is an early indicator of engine efficiency loss, dirty air filter, degrading oxygen sensor, failing thermostat, worn spark plugs, fuel system contamination. Any condition that reduces combustion efficiency will manifest as a gradual decline in Trip B averages months before it triggers a diagnostic code. You are carrying a diagnostic tool in your dashboard that monitors your engine's health continuously, for free, with no equipment required, and that provides early warning of developing problems if you use it the way it was designed to be used. Japanese drivers are taught to monitor Trip B the way you monitor your body weight, not obsessively, consistently. A pound up or down means nothing. A consistent trend over months means something. A tenth of a mile per gallon variation in fuel economy means nothing. A consistent half mile per gallon decline over 3 months means your engine is asking for attention. And that attention, provided early, costs a fraction of what the repair costs if you wait for the check engine light. I have given you 5 controls today. 5 buttons, switches, and systems that are already in your car, that you already interact with, and that you have been using at a fraction of their designed capability because the knowledge that unlocks their full functionality was never transferred to you. Recirculation management that saves fuel and prevents hundreds of dollars in mold remediation. Cruise control techniques that reduce fuel consumption and brake wear while improving safety. Auto hold usage that reduces drivetrain wear and fuel waste at every stop. Headlight management that closes dangerous visibility gaps the auto system creates. Trip computer monitoring that provides free, continuous engine health diagnostics. None of this is hidden in the sense that you need to hack into your car's computer to access it. All of it is hidden in the sense that matters. Hidden behind a delivery process that does not educate, a service model that does not inform, and a cultural gap between the engineers who designed these systems and the drivers who use them that nobody in the Western automotive industry has any financial motivation to close. In Japan, this gap does not exist. In Japan, a driver's relationship with their car begins with a 45-minute education from a technician who explains not just what every button does, but why it exists, when to use it, and what happens to the car when it is used incorrectly. That education is the foundation of an ownership experience where the driver is an active, informed participant in the car's health and longevity. In Western markets, the driver is a passive consumer of a product they do not fully understand, generating revenue for an industry that benefits from that lack of understanding. Today you stopped being passive. Today you started understanding your car at the level its engineers intended. And every mile you drive from this moment forward, using these controls the way they were designed to be used, is a mile that costs less, lasts longer, and protects you better than the miles that came before it. That is not an exaggeration. That is the engineering reality behind every button I just explained. If this changed something in how you think about your car, subscribe to Secret Japanese Garage right now. This channel exists to close the gap between what Japanese engineers built into your car and what the Western market chose not to tell you about it. Every video on this channel is a piece of that bridge. Every subscription tells me to keep building it. Share this with someone who drives a Japanese car and has never thought about their recirculation button, their cruise control cancel function, their auto hold system, their headlight switch, or their trip computer as anything more than basic features, because that person is losing money, losing efficiency, and losing safety margins every single day through the incorrect use of controls they already have. That loss stops the moment they watch this video. Hit subscribe and turn on notifications because next week I'm going to show you something that Japanese mechanics check on every car in the first 30 seconds of every service appointment. A single observation that tells them more about how you drive and how your car is wearing than any diagnostic scan tool can reveal. It takes no equipment, it costs nothing. It is so simple that once I show you, you will be able to do it yourself in your own garage in less than a minute. And what it reveals about your car's current condition and future reliability will change how you think about every service visit you have ever paid for. I will see you there.